Hi everyone, my name is João Henriques and I will present a work entitled Biometric Data Capture as a way to identify the lack of physical activity in daily life. This presentation has the following outline. We'll start by introducing the subject of this paper, next we'll provide some background, and then the related work will be also presented. The underlying architecture for our system will be introduced. In the next step, we will detail an experiment and the results will be presented. Finally, the conclusions are made. The pandemic times we are living have contributed to reduce the physical activity, which impacted negatively the human health. Recently, biometric data has gained attention, mostly due to the massive use of daily life devices like smartwatches, smartphones and laptops. Mostly of those devices are equipped with embedded sensors to measure biometrics parameters. Besides having biometric sensors, mostly of them also have enhanced with some wireless communication technologies, for instance Bluetooth, Wi-Fi, radio frequency, allowing them to share data to perform remote actions. Due to this widespread of integration with users' lifestyles, mobile devices can support personal activities anywhere and anytime. The do-it-yourself community has been contributing to the development of low-cost and easy-to-use hardware platforms targeting biomedical engineering and equipped with multiple sensors useful for a wide range of applications. Vitalino is one of those open hardware platforms explicitly designed to suit the needs of physiological computing community. Vitalino device is also low cost and highly versatile hardware framework designed to allow anyone from students to professionals, app developers to create projects and applications with physiological sensors. These are the building blocks for our system. Base architecture, we have the person, the Vitalino device, the smartphone, the FTP server, and the processing unit. In this experiment, we aim to understand the lack of physical activity and the relationship with the critical phase that we are trying to pass through. SCG and accelerometer sensors from Vitalino will provide the biometric data such as the measures for the heartbeat and also the physical movement. Biometric data will be sent to a server which will process that signals, and finally the collected information will be graphically displayed and resumed to better visualization and comprehension. Selected sensors, analyzes for different activities, spine, seated, deep breathing and recover after exercise. Our system comprises the following steps in a processing pipeline. The first step was to obtain the data from a Vitalino device, specifically from two sensors used in this study. In this case, an ACG and accelerometer sensor. The procedure was to establish a connection between Vitalino device and Android smartphone using the Open Signals applications to collect that data. Open Signals is the software from Lopes to create the creators of Vitalino devices. They allow to capture data from sensors and save it to a text file that corresponds to the sensor's outcome results. In the next step, data in that text file will be sent to FTP server. There a data watcher process will monitor that FTP server, and specifically the FTP folder where those files will be uploaded, that monitoring process will look up for new files. Then a Jupyter Notebook file for processing the data is created. Finally, a generated file can be opened in a Jupyter server or a Jupyter lab, rendering the charts with sensor metrics. From the collected data, results from SEG and ACC sensors can be seen in the chart presented in those two figures. The first figure depicts 80 minutes, and the second one corresponds to a portion of 2 hours and 80 minutes. The data to be collected in chunks due to the large volumes of data that is being captured, making them it more difficult to handle in devices like mobile phones, smartphones, and even more difficult to process it and transform it into a much simple option will be to have a laptop computer to process that data. Shown in both of these charts, collected data depicts a correlation between ECG and accelerometer signal spikes. Such data represents periods of time that corresponds to the movement of depicting some human activity. Although the periods described in those charts are not from a full day, from a continuous movement, we observe the same pattern of motion or leg movement in case of the subject of the person. So as we suspected from the beginning of this work. This work demonstrated how to implement a system that will capture, process, and display biometric data collected from sensors in individuals. The object was to correlate the lack of movement and the sensor from the sensor data to sensors were used to achieve the proposed goal. ECG and accelerometer sensors were adequately integrated in the single board computer, a Vitalino device. It could make the capture and then the data collected is sent to a FTP server to further to be processed to a Jupyter notebooks where the data will be rendered in charts. The conclusion from this work is that the implementation of this system was an excellent means for learning purpose. Finally, it was helpful for population that tends to be more sedentary in these pandemic times we are living, or this solution can be applied, for instance, in the nursing homes. In the future, can be considered additional sensors for monitoring and analysis of biometrics and indicators related to the well-being of individuals. Finally, machine learning algorithms can be explored for processing data and to get new insights. So thank you for your attention. If you have some questions, so please let me know. Thank you.